All right, children. So can you see the object I'm presenting? Okay. So the solid which you see is a cube. And a cube has 6 square surfaces. A cube has 6 square surfaces. So see the 6 surfaces? One surface on the top, another one below, and 4 surfaces vertically. 1, 2, 3, 4. Front face, back face, the side faces, the left and right face, top face, bottom face. So like this, a cube has 6 surfaces. Each surface is a square. Each surface is a square. Top face, bottom face, the side faces, left and right face, front face and back face. Now every face is a square. And we know that the area of a square is a square. Now in all, this cube has 6 surfaces, 6 square surfaces. So the total surface area of this cube will be 6 into a square, because one face, the area is a square. So 6 faces, 6 into a square, 6a square. So the total surface area of this cube is given by the formula 6a square, square units. Now we say that the cross section of a cube is a square. The cross section of a cube is a square, because see, when you see one face of the cube, you know, it's a square. You can also understand the solid cube like this. Supposing you have many square, square pieces of paper, say, of side 5 centimeters. Okay. You have many paper cutouts. The cutouts are in the form of a square, and the side of the square is 5 centimeters. You have many pieces. You have many identical squares. You have many identical square cutouts, each of side 5 centimeter. So now what you do is you stack them. You stack these square, piece of paper to a height of 5 centimeters. You stack them to a height of 5 centimeters. Then you get a solid. The paper is a plane figure. The paper is a plane figure. Now, when you arrange or when you stack the papers, when you place them one over the other, they're all identical. They're all identical. Each of them are squares of side 5 centimeters. So you stack them to a height of 5 centimeters. So then what happens? The length is 5, the breadth is 5, the height is also 5. So when you stack these papers to a height of 5 centimeters, you see a solid, and this solid is a cube. It's a cube because the length is equal to the breadth is equal to the height, in this case 5 centimeters. So we say that the cross section of a cube is a square because you get a cube by stacking up identical squares to a specific height. Whatever is the side of the square, you need to stack the square piece of paper to that height. So if the side of the square is 10 centimeters, then you'll have to stack the squares to a height of 10 centimeters. Only then the length, breadth, and the height will be the same. So the cross section of a cube is a square. Now, volume of a solid which has a uniform cross section. Now, a cube has a uniform cross section. The uniform cross section of a cube is a square. The uniform cross section of a cube is a square because for the same reason, because it's a solid which is, produced or generated by stacking identical squares. to that desired height. So a cube is a solid which has a uniform cross section. And the uniform cross section of a cube is a square. Now, volume of any solid with a uniform cross section is given by area into height. The volume of a solid that has a uniform cross section is given by area into height. Now, what's the area of the square? A square. Into height. What's the height of the cube? A. Because whatever is the side of the cube is the height, right? So A square into A. A square into A is A cube. And that's how we have the formula. Volume of a cube is equal to A cubed cubic units. Volume of a cube is equal to A cubed cubic units because it is volume is equal to area into height. Area is equal to area meaning area of the uniform cross section. Area of the uniform cross section is A square into height is A. So A square into A cube. A cube cubic units is the formula to find the volume of a cube. Total surface area, we just understood. The total surface area, it has 6 square faces. Area of one face is A square. So 6 faces will be 6A square. Now, if you want to find the area of only 4 faces, if you want to find the area of only 4 faces, say you want to find the area of the, you want to find the curved surface area. See, these are the standing faces. 1, 2, 3, 4. There are 4 vertical faces and 2 horizontal faces. There are 4 vertical faces here. This one, 1, 2, 3, and 4. 4 vertical faces. These 2 faces, the top and the bottom face, they're horizontal. The top face and the bottom face are horizontal faces. The remaining 4, front, back, left, right, these faces are vertical faces. They're like standing, so vertical. Okay, they're standing, so vertical. The top and the bottom face, they're like in the sleeping position, horizontal faces. So if you want to find the curved surface area or the area of the standing faces, so like this one. All right. If you want to find the curved surface area, the area of the 4 vertical faces. So one face is A square. 4 faces will be 4 into A square. Here every face is a square. Every face is the area of A square. So 4 faces, 1, 2, 3, 4 faces, 4A square. Supposing you want to find the area of 5 faces, 5A square. 6 faces, 6A square. Because every face has an area of A square. So that's about area. Okay, let me show you the presentation. So you can see here, children, what we just understood. Volume is equal to area of the uniform cross section into height. The uniform cross section is a square. The area of the square is A square. So A square into A, which is A cubed cubic units. The curved surface area or lateral surface area. Curved surface area is also called the lateral surface area. Yeah, I didn't tell you this. Let me tell you that first. So the lateral surface area. So again, for a solid that has a uniform cross section, for a solid that has a uniform cross section, the curved surface area or the lateral surface area is given by perimeter into height. Like volume is area into height. Volume is area into height. In the same way, the curved surface area or the lateral surface area of a solid that has a uniform cross section is given by perimeter of the cross section into height. So what is the perimeter of a square? What's the formula to find the perimeter of a square? 4A. 4A.
4 into side.
4 into side. 4A into H. Perimeter of the uniform cross section into height. 4A into A. 4A square. 4A into A. 4A square. A square, A square, A square, A square. 4A square. 4 faces of 4A square. It's also understood like this. The curved surface area or the lateral surface area of a cube. A cube has a uniform cross section. is given by perimeter of the uniform cross section into height. Volume is area of the uniform cross section into height. Curved surface area is perimeter of the uniform cross section into height. Now the cross section is a square. The perimeter of a square is 4a into height a, not height of the square. Square does not have a height. Height of the cube. Height is the height of the cube, which is a. So 4a into a, which is 4a squared. And that's right, no? Because curved surface area has 4 vertical faces. Curved surface area has 4 vertical faces. Each face a square. 4 faces, 4a square. So the total surface area is CSA plus area of the base plus area of the top. The total surface area is a curved surface area plus area of the base plus area of the top. So 4a square plus area of the base, which is again a square, a square, area of the top, a square. So 6a square, the total surface area, the area of all the 6 faces. Okay. So what have we understood? Area of the 4 vertical faces is 4a square. Area of the 4 vertical faces and the 2 horizontal faces is 6a square. If you want the area of 5 faces, so in some situation, if you have to find the area of 5 faces alone, then it will be 5a square. It will be 5a square. And one more thing you'll have to remember is the length of the diagonal of a cube. The length of the diagonal of the cube is given by the formula √3a units. The length of the diagonal of a cube is given by the formula √3a units. Is this fine, children? All right. Now coming to cuboid. So we understand the cuboid in the same way. Now a cuboid, I just have, okay, a cuboid. I hope you can see this. Yeah. A cuboid, again, is a solid whose cross section is a rectangle. So if you have many identical rectangles cut out from paper, okay, so you have many identical rectangles, paper cutouts of rectangle, okay, whatever dimensions, whatever dimensions. So you stack the rectangles. You stack the rectangles to any height because cuboid, no, so nothing specific. When it's a cube, length, breadth, height, all must be the same. It's a cuboid, whatever the dimensions. So you stack these rectangles to any height. The solid you obtain is a cuboid. So a cuboid is a solid which is generated by stacking identical rectangles. Stacking meaning placing them one over the other. Okay, uniformly, not haphazardly, uniformly. So when you stack identical rectangles to any height, the solid generated is a cuboid. So we say that the uniform cross section of a cuboid, the uniform cross section of a cuboid is a rectangle. The uniform cross section of a cube is a square. The uniform cross section of a cuboid is a rectangle. Cube and cuboid are solids. They are 3-dimensional. Their cross sections are 2-dimensional. Cube is a solid. It's 3-dimensional. Its cross section is 2-dimensional. It's a square. A cuboid is a solid. It's 3-dimensional. Its cross section is a rectangle, which is 2-dimensional. It's a plane figure. So volume of a cuboid. So volume is area into height, area of the uniform cross section into height. Volume is equal to. Online students, I've shared my screen. It's visible, right?
Yes, ma'am.
Yes,
Yeah. Okay. So volume is equal to area of the uniform cross section to height. Now the cross section is rectangle and the area of the rectangle is L into B. So L into B into H. So LBH cubic units. L into B into H or LBH. LBH meaning L into B into H. Cubic units is the formula to find the volume of a cuboid. See, I've just written volume. Don't wonder volume of what. See, I've given the heading here. Volume, I'm sorry, cuboid. I've given the heading. So all the formula here are of the cuboid. Okay. Now, curved surface area or lateral surface area. Same, understanding. So the curved, so cuboid has a uniform cross section. So its curved surface area or lateral surface area is defined as perimeter of the uniform cross section into height. Volume is area of the uniform cross section into height. Curved surface area or lateral surface area is perimeter of the uniform cross section into height. So rectangle, perimeter is 2 into L plus B. Okay, so perimeter of a rectangle 2 into L plus B into H. So that is 2 into L plus B into H square units. Area square units. Volume cubic units. All right. Now you can also understand CSA or LSA like this. See here. Now when you look at the cuboid, cube. So sorry, cuboid. I'll just hold this only. It's a cube, but let's just look at it as a cuboid. Now, what is the area of this front face, children? What will be the area of the front face? Length into height. See, this is the height of the. This is a cube, children, but let's treat it as a cuboid. This is the length. This one is the length of the cuboid. This one is the breadth. This is the breadth. This is the height. This one is the height. This is the length. This one is the length. This is the length. This is the breadth. This one is the height. The vertical thing is the height of the cuboid. All right. Now let's understand the area of the front face. How do we find the area of the front face? The front face is a rectangle. The front face is a rectangle. How do you find the area of this rectangle? Length into height. See, we are not changing. It's L into B, right? Length into breadth. But what is length into breadth here? Length into height, H. L into H, right? And the same thing behind the back face. The area of the back face also will be L into H. In a cuboid, the opposite faces are congruent. They're identical. In a cuboid, the opposite faces are congruent, meaning they're identical. The top face and the bottom face, the front face and the back face, the left face and the right face. Okay, they're identical. So the front face, area is L into height, H. L into H, length into height, L into H. Same thing behind, L into H. Now the side face, this side face is the breadth. For the side face, this is the breadth. Breadth into height, B into H, B into H. See, this is the side face, this is the side face. Breadth into height. This one is the height, B into H. So this one is B into H, this one also will be B into H. So the front face is L into H, back face also L into H. Side face B into H, this side face also B into H. The top face will be L into B. The area of the top face, the area of the top face will be L into B. The area of the bottom face also will be L into B. Top and bottom face is L into B. Front and back face, L into H. Right and left or left and right, whatever, faces B into H. Breadth into height. So we can also derive the formula to find the CSA or LSA like this. This is the area of the front face, children. Length into height. Area of the front face. See, curved surface area meaning area of 4 faces. Front, back, left, right. Curved surface area is area of 4 faces. Top and bottom not included. Horizontal faces not included for curved surface area, only vertical faces. So this is the area of the front face, length into height. The same thing will be the area for the back face, L into H. This is the area of the side face, left or right, whichever face, breadth into height. So the other side face also will be breadth into height. So say this is the front face, this is the back face, this is the left face, this is the right face. So LH plus LH is 2LH, BH plus BH is 2BH. So now 2H is common. You can see here 2H is common. So 2H common, in the bracket you would have L plus B. In the bracket you would have L plus B. See, 2H is common, no? 2H is common. So in the bracket you will write L plus B, L plus B. So that's how we get this formula. 2 of L plus B plus 2 of L plus B into H, or 2 into L plus B into H. And that's what we have here also. It's another way of understanding. You can go by the definition. CSA is equal to perimeter into height. This is the definition of a this is the definition of the curved surface area of a cuboid. I'm sorry. This is the definition of the curved surface area of a solid that has a uniform cross section. If a solid has a uniform cross section, then its curved surface area or the lateral surface area is defined as perimeter of the cross section into height. So going by the definition, we got the formula. This is without using the definition, by actually considering the faces and calculating the areas and then finding their sum. The OR part is calculating the area of the faces separately and finding their sum to find the curved surface area or the lateral surface area. Okay, so the total surface area will be all the 6 faces. So CSA plus area of top plus area of the base. So I've again written, how do you find that CSA? This one is CSA, right? So I've written the same thing here. You can see that here. Now area of the top, L into B. Area of the base, L into B. Let me repeat that. Let me repeat this. Curved surface area. You can see what I've written here. This one, I've repeated that. All right. Area of the top, L into B. Area of the base, L into B. So we have 2LH, 2BH, 2LB. That's L, children, not 1. It's L. L. It's not 1. Okay. So 2LB plus 2BH plus 2LH. 2 common, we have LB plus BH plus LH square units. So this is the formula to find the total surface area of a cuboid. 2 of LB plus BH plus LH square units. So what have we understood? Area of the 4 vertical faces is 2 into L plus B into H. Area of the 6 faces, all the 6 faces, is 2 of LB plus BH plus LH. And if you want to find the area of 5 faces, for in some case, if you want to find the area of 5 faces, all right, then it is area of 4 faces plus the area of 1 face. Area of the 4 faces is 2H into L plus B. Area of 5 faces, I mean the CSA plus either the bottom or the top. Okay, so this is the CSA plus this could be the area of the bottom or the top, whatever. So if you have to find the area of 5 faces, see, if it's a cuboid, you'll wonder, if it's a cuboid, it should have the 4 faces. Without the 4 vertical faces, it's not a cuboid. It cannot be a cuboid. So curved surface area is definitely there. See, now if you take the example of like the overhead tank, water tank. Okay, the overhead water tank, it's cuboidal, right? Now imagine that without a lid. Imagine that without a lid. So then it will have only the 4 vertical faces and the bottom face, right? The top is not there. Why? Because it's an open tank. It's an open tank. Okay. So there can be situations where the cuboid will have only 5 faces, the curved surface area and the bottom covered. The top is open. The top is open. The top does not have a lid. In that case, the area will be 2h into L plus B. See, you can also write 2 into L. See, this both are the same, children. 2h into L plus B is the same as 2 into L plus B into h. It's the same. H here. And then the length of the diagonal of a cuboid is given by the formula root of L square plus B square plus H square units. Like a cube, it is root 3a units. Cuboid, root of L square plus B square plus H square units. Okay, so that's about the formulae related to cuboid. Cylinder. Cylinder. Okay. So this object is cylindrical, right? So this is the curved surface area. This one is the curved surface area of the cylinder. This one. This is the curved surface area of the cylinder. This is the area of the top, and this is the area of the base. This is the base, this is the top, and this is the curved surface area. Now, a cylinder or a right circular cylinder. This one is a right circular cylinder. A cylinder or a right circular cylinder also has a uniform cross section. So this solid can be obtained by stacking identical circles to any height. Congruent circles, identical circles to any height. So say you have circles of radius 7 centimeters. You have many identical circles of this radius 7 centimeters. So you stack them. You stack the circles. You arrange the circles one over the other. You stack them up to any height. Now a circle is a plane figure. A circle is a plane figure. When you stack this plane figure to a particular height, the solid generated is a cylinder. The solid obtained is a cylinder. This one is called a right circular cylinder. I'll tell you why right. Circular because the base is circular. I'll tell you why it is right. Okay. So right circular cylinder. Uniform cross section is a circle because it can be obtained by stacking congruent circles. Congruent circles meaning identical circles to any height. So again, so to find the volume of the cylinder, it is the area of the uniform cross section to height. And to find the curved surface area of the cylinder, it is the perimeter of the uniform cross section into height. I repeat, whenever a solid has a uniform cross section, not all solids have a uniform cross section like a cone. A cone does not have a uniform cross section. A cone is a solid. A cone is a solid, but it does not have a uniform cross section because you cannot stack many identical things to form a cone. It may look circular, but the circles should keep increasing in radius. So you cannot get a cone by stacking many identical plane figure. No, so a cone does not have a uniform cross section. Sphere, something spherical. Okay, a spherical object or a sphere does not have a uniform cross section. A hemisphere does not have a uniform cross section. So cubes, now we will be, I think, working only with cubes, cuboids and cylinders. And I'll also do hollow cylinder for you. Okay, we'll not talk about whether it is needed for 8th or not, but anyways, it's a part of it comes with cylinder. So cylinder, hollow cylinder. So this is what we'll see in 8th standard. In 9th standard, it will be cone, hemisphere, and sphere. So for 8th standard, we restrict our discussion to these solids: cube, cuboid, cylinder, hollow cylinder. So cube has a uniform cross section. Cuboid has a uniform cross section. Cylinder also has a uniform cross section. And whenever solids have a uniform cross section, Their volume is defined as area of the uniform cross section into height, and their curved surface area is defined as perimeter of the uniform cross section into height. Okay, so let's go ahead and check the formula for cylinder. Volume. Volume. Area of the uniform cross section. Yeah. No. Yeah, children. So volume, area of the uniform cross section into height. Circle, uniform cross section is a circle, and area of a circle is pi r square into h, pi r square h, cubic units. CSA, perimeter into height, perimeter of a circle, perimeter, 2 pi r, 2 pi r, circle, perimeter, circumference, 2 pi r. Okay, so 2 pi r into height, height of the cylinder, h. Height is the height of the cylinder, h. So 2 pi r h square units. The total surface area will be the curved surface area. This is TSA meaning total surface area, curved surface area plus area of two circles. So CSA is 2 pi r h, area of the two circles, pi r square plus pi r square. Okay, two circles, pi r square plus pi r square. So 2 pi r h plus 2 pi r square, because pi r square plus pi r square is 2 pi r square. All right. So what's common? 2 pi r. 2 pi and 1 r is common. So in the bracket, you would have h plus r. Or r plus h. So when you take out 2 pi r common, in the bracket, you get h plus r, which can also be written as 2 pi r into r plus h. 2 pi r into r plus h or 2 pi r into h plus r, both fine. So this is the total surface area of a cylinder. Now, supposing the cylinder is open at the top. Now, can you just pick that? So I've just removed the lid. I've removed the lid of the cylinder. Okay, I've removed the lid of the cylinder. Now there's no material here. There is a circular opening, but there's no material. This plastic is not covered here. So this cylinder is open at the top. It's open at the top. See, you will find area only if the material is used on that surface. This one is a cylinder, but you will not find the area of this portion because there is no material used there. When you're finding the area, you're finding the area of the material. Whenever you find the area, you're finding the area of the material used. Now, where is the material used here? Whatever plastic or whatever is covered here for the CSA, and then the bottom is also covered. The circular part at the bottom is covered. Top is open. So if you have to find the total surface area of the cylinder, so we shouldn't be misled with the word total. They'll say total. Find the total surface area. Find the total surface area. So the total surface area of this cylinder will be wherever the material is used. So is the material used here for the CSA? Yes. So you should find the CSA. Is the material used for the base? Yes. So you should find the area of the base. Is the material used here on the top? No, it's open. There's no material there. Now there's material. Now there is material on the top. It's covered. There's material. If there is material, you should find area because there's a surface. Now just imagine, see, finding area is all about painting the outer surface. You can just take it like that. Finding the area is all about painting the external surface. So if at all you have to paint the cylinder, where all will you paint? You'll paint the curved surface area because there is the surface to paint. So you'll paint the CSA. Then where will you paint? The bottom circle you'll paint. Then you want to paint the top, but there's nothing. If you try to paint on the top, where will you, meaning there's nothing on the top, right? Where will you brush? Nowhere. There's no material. But if there is this lid, then you can find the area of the top. Now you can brush this part. So that's what it is. Whenever you find area, you should find the area of all those surfaces where the material is used. If there's no material there, you cannot find area. I mean, there's no area there, no material used. Okay. So in the case of a cylindrical tumbler, okay, you can imagine a cylindrical tumbler. So a tumbler is open at the top. Normally, a tumbler does not have a lid. Okay. A tumbler does not have a lid. If it has a lid, it should be given that this tumbler has a lid. Whereas normally tumbler does not have a lid. So if it's a cylindrical tumbler, steel tumbler, cylindrical steel tumbler, and the question is to find the total surface area of the steel used to make the tumbler. The question is find the total surface area of steel used to make the cylinder. Don't go by the word total. Total means that the question is where all the steel is used, find all that area. That is the question. So where all is the steel used? CSA? Yes. Bottom? Yes. Top? No. Then you cannot find that area. So you should find CSA. What's the formula for CSA? 2 pi RH. Yeah. For CSA, it is 2 pi RH. And what's the area? What's the area of the base? Pi r square. That's all. This is the formula. If you want to find the total surface area of a cylinder, open at the top. If you want to find the total surface area of a cylinder, open at the top. Don't go by this word total. Total does not mean this formula. Total for this cylinder open at the top will be 2 pi RH CSA plus the area of the base pi r square. This is the total surface area. Now, supposing you make a cylinder using a piece of paper. Okay, so you imagine a cylinder made from paper. Okay, so we roll this paper, we bring the opposite sides together. Okay, a rectangular sheet of paper. We bring the opposite sides together. Okay, so it's a circle. But how is a circle? It's open at the top and the bottom. The circle is open from the top and the bottom. You can see through. So where all is the paper used? Only along the CSA. There is no paper covering the top circle. There is no paper covering the bottom circle. So in this case, if at all the question is find the total size, a cylinder like this. Okay, a cylinder like this, which is open at the top and bottom. A cylinder like this, which is open at the top and bottom. Okay, so how did we make the cylinder? A rectangular sheet of paper. We just brought the opposite sides together. And made a cylinder like this. So in this cylinder, where there is no material used on the top and the bottom, it's a hollow cylinder. It's open at the top and bottom. If you have to find the total surface area of this cylinder, don't use the formula 2 pi r into r plus h. Where all is the material used? Only for CSA. There is no paper on the top. There is no paper below. So what is the total surface area of this cylinder? Only CSA. 2 pi RH. 2 pi RH. That's all. Wherever paper is used, only that area you'll have to find. So paper is used only for the CSA. So this only CSA is this one. TSA also is this one. For this cylinder which I just showed you using the paper. If they ask you to find the CSA, it's 2 pi RH. TSA, that also is 2 pi RH only. The CSE, TSE, both are the same in this case. Yeah, children here and online students, any questions? Lakshana, Shreya, Aishwarya, Surya, and Saujanya. Raise your hand. Online students, raise your hand. Aishwarya, Surya, Lakshana, Shreya. Saujanya, are you there? Shreya says no doubts, ma'am. Okay. What about Lakshana? Any questions?
No, ma'am.
Aishwarya?
No, ma'am, no questions.
Surya?
No, ma'am, no doubts.
Here, children? Right. Yeah, please write down, children. Please write, children. Done. Finish writing, online students? Finish it? Not yet, huh? Okay, okay. Yeah. Done writing, children? Students. Okay.
On the last line,
Okay, yeah.
Done, ma'am.
Yeah. Should I wait for anyone? Done, all of you?
I'm in the last second line. 1 second.
Okay.
Yes, ma'am, I'm done.
Done. Yeah. Yeah. Write down this one. Done writing, children?
Just a second, ma'am.
Okay. Yeah. Finish, children?
On the last line, ma'am, just a second.
Yeah.
Done, ma'am.
Okay. All right. All right, children. So this question, the dimensions of a cuboid are in the ratio 5:3:1, and its total surface area is 414 meters square. Find its dimensions. Okay. So we are given the total surface area. So let's write that first. Okay. Total surface area. Before that, the ratio is given. So how do you assume? Let the length of the cuboid, right? Let the length of the cuboid be 5x meters. Let the breadth of the cuboid be 3x meters, and let the height of the cuboid. Let the height of the cuboid be 1x or simply x. 1x or simply x. Okay, 1x, which is nothing but x meters. Now we are given the total surface area. Total surface area of the cuboid is equal to 414. Now the formula to find the TS of a cuboid is 2 of LB plus BH plus LH is equal to 414. So substitute 2 into L into B, 5x into 3x plus, see the usage of the brackets, children, plus B into H, 3x into x plus LH, L into H, 5x into x. This is L into B plus B into H plus L into H is equal to 440. Now, children, you'll have to solve this and find the value of x and hence find the dimensions. Once you find the value of x, you can see there is one equation with one unknown x. One equation, one unknown x. So you can easily solve this and find the value of x. And once you get the value of x, 5x, 3x, and 1x will give you the dimensions of the cuboid. Please finish it. Just excuse me for 5 minutes, children. Complete this answer in the meantime, I'll get back. Thank you, children. I'm back. So you have the value of x ready with you now? What's the value of x?
Ma'am, I got it as 3.
3. Okay, let me see. So 2 into 5 3s are 15, x into x, x square, plus 3 x into x, x square, plus 5 x into x, x square is equal to 414. Now you can bring this 2 down for division. And here in the bracket, we'll need to, they're all like terms, all x square terms. Inside the bracket, we have 3 terms and all the 3 terms are x square terms. So they're like terms, which can be simplified. You can find their sum. So 23. Okay, so 23. So you can also write 2 into 23 x square is equal to 414. So x square is equal to 414 divided by 2 into 23. You can also write it as 46 and bring 46 for division. And that is okay. Okay, so x square is equal to 2 ones are 2, 2 not 2 times. How many times, children? This one? Nobody's helping me. 23, how many times, children? Oh, 207. No, I went. Oh, sorry, 207. Sorry, 207. Yeah, so how many times? 9 times? Okay, 9 times. So x square is equal to 9. X is equal to the square root of 9. X is equal to 3. X is equal to 3. Very good. So now length, breadth, and height. So now L is equal to 5 into 3. 5 into 3, 15 meters. Correct. B is equal to 3 into 3, 9 meters. And H is equal to 3 meters. To the X. Anyone, if you've made any careless mistake, please repeat your answer. Done? None, children? Shall we move to the next one?
Just a second, ma'am. I'm writing it down.
Okay. No, but I'm sorry, since I already was away for some time, can you just take a screenshot? There's a few who have not finished. Complete it later, no? Let's go to the next one.
Taken,
I'm
ma'am.
sorry to say that.
Yes, ma'am.
Yeah.
Right, ma'am. I've taken a screenshot.
Yeah, thank you. Yeah. 3 metal cubes with edges 6 centimeter, 8 centimeter, 10 centimeter are melted together and formed into a new cube. Find the volume and the surface area of the new cube. So now there are 3 metal cubes, 3 different metal cubes. One cube of edge 6 centimeters. Another cube slightly bigger, edge 8 centimeters. The third cube still bigger, edge 10 centimeters. So like this, you have 3 metal cubes. Now it's a metal, right? So you can melt it. The metal is melted. And now all these 3 cubes are made into one big cube. It's melted. The 3 cubes are melted and molded into a big new cube. One big new cube. We need to find the volume and the surface area of the new cube. So remember this, whenever, a solid or here we have three solids. When they are melted and transformed into a different solid, the volumes will be the same in both the cases. Assuming that there is no wastage in the conversion process. Assuming that there is no wastage during the conversion process. What is that conversion process? These three cubes, the metal, meaning the three cubes, they are melted and they're made into one big cube, right? So in this conversion process, assuming that there is no wastage, the volume of all these three cubes will be equal to the volume of that big cube. The volume of all the three cubes will be equal to the volume of that new cube. Okay, so that's how we start the answer. We write that first. Volume of the three cubes is equal to volume of the new cube. Now, when you write like this, we know that, so here we have all the values, right? This is what we have to find. So I'll write it the other way. I'll write it the other way. Volume of the new cube. Volume of the new cube is equal to volume of the three cubes. Three cubes. Now, volume of a cube. Formula A cube. Okay, I'm going to use a capital A cubed is equal to. Now, to represent the volumes of the three other cubes, I'm going to use their edges as A1, A2, and A3. Okay. So volume will be A1 cubed plus A2 cubed plus A3 cubed. A1 is the edge of the first cube. A2 is the edge of the second cube. A3 is the edge of the third cube. And capital letter A is the edge of the new cube. Now, given these edges, what will be their volumes? You'll have to cube the edge, right? Cube the edges. So A1 cubed is the, okay, let me write one more line. Let me just write this. All right, so A cubed is equal to volume of cube 1, A1 cubed, edge cubed, plus volume of cube 2, edges A2 cubed, plus volume of cube 3, edges A3, so A3 cubed. So A cubed is equal to A1 6 cubed plus 8 cubed plus 10 cubed. So A cubed is equal to 6 cubed is 216, 8 cubed is 512, and this is 1000. So A cubed is equal to, what's the sum, children? 1728. 1728. So A is equal to the cube root of 1728. A is equal to So A is equal to the cube root of 1728. You need to find this. Okay, you need to find this. So that is the edge of the new cube. This will be the edge of the new cube. Now find the volume. You know the edge. How do you find the volume of the new cube? A cubed. And how do you find the surface area? 6A square. Surface area is equal to 6A square. Use a capital letter A. That's all. All right. Please finish the answer. Take down the question. You don't have to write. Don't write all this. It's enough if you write this. Just start from here, children. Start from here.
Ma'am, I think it's the cube root of 12.
Cube root of
12.
12, correct. A is equal to 12. So this working to find the cube root of 1728. If you've forgotten, please open to the chapter cubes and cube roots after the class or sometime tomorrow. Go through and please do it yourself. You need to use the prime factorization method and find the cube root of 1728, which is 12. Now the volume and surface area. Volume of the new cube. Volume of the new cube is equal to A cubed. So what is it? 12 cube, which is 1728 centimeters, is it? Centimeter. Centimeter cube. What about the surface area? TSA of the new cube is equal to 6a square. A cube cubic units, 6a square units. So 6 into a square, a is 12. So 6 into 144, carried over 24, 6 to 864 centimeters squared. 864 centimeters squared. Please complete the answer, children.
Done, ma'am.
Yeah. Next one. The area of a trapezium is 384 centimeters squared. Its parallel sides are in the ratio 3:5. And the distance between them is 12 centimeters. Find the length of each parallel side. So let the parallel sides be 3x centimeter and 5x centimeter. Why? Because it's given that the parallel sides are in the ratio 3:5. The parallel sides are in the ratio 3:5. So let the sides be 3x centimeter and 5x centimeter. Now you're given the area. So write that area of trapezium is equal to 384. Write down that information. Area of trapezium is equal to 384 centimeters square. Now, what's the formula to find the area of a trapezium? Half into sum of the parallel sides. So we call them A plus B. Okay, half into sum of the parallel sides, A plus B, into the distance between them, H. The formula to find the area of a trapezium is equal to half sum of the parallel sides into the distance between the parallel sides. So symbolically it is like this, half into A plus B into H is equal to 384. So half into A plus B, sum of the parallel sides, 3x plus 5x into H, that is 12, is equal to 384. Now it's multiplication, so you can cancel. 2 ones are 2 6 are. 3x plus 5x, 8x, not 8x square, 8x. 3x plus 5x is 8x is equal to, see, you can also put the 6 here, or you can bring the 6 for division. 8x into 6 is equal to 384. So x is equal to 384 divided by 8 into 6. So simplify this and find the value of x, and hence find the length of each parallel side. Once you find x, 3x and 5x will give you the lengths of the parallel sides. Yeah. Do this, children.
Yes, I got the answer, ma'am.
Yes, ma'am, even I did.
Yeah, what's the value of x?
288.
8, ma'am.
No, 8. The value of x is 8. All right, very good. Very good. I just go with you all. I'm not checking that. I'm sure it must be right. Now we need to find the length of each parallel side. So length of the parallel sides. Are 3x, right? So 3x, which is 3 into 8, 24 centimeter, 5x, 5 into 8, 40 centimeter. Correct? Yeah. Once we get the value of x, use that in 3x and 5x and find the lengths of the parallel sides. Yeah. All right. Next one. In a quadrilateral ABCD, AB is parallel to DC. Okay, so in a quadrilateral ABCD, let me just draw a rectangle first, and then we'll modify this to satisfy the information given. I'll just first represent the or I'll just use the information given in a rectangle, and then we'll modify that to somewhat look like what is given in the question. So let me just mark ABCD like this. AB is parallel to DC. Okay, AB is parallel to DC. AD is perpendicular to AB. AD, this is AD. It's perpendicular to AB. So this one is 90 degrees. And AB is 8. 8. DC, BC 5. DC 5, BC 5. Okay. Find the area of the quadrilateral. So now we get some idea. No? So now see this. Like this. This is perpendicular. So like this. This is 8. So longer. This is 5. So shorter. And then join like this. I'll do it again. See, first, I simply drew a rectangle. You can even draw a square, whatever. And mark the details given in the question. Now, with the help of this figure, you can draw the actual rough figure. This one is a rough figure for the rough figure. This one is a rough figure for the rough figure. Now the rough figure, all right? Because the real figure you can get only by construction, by actually constructing. So what we are going to do is a rough figure, and this one is the rough figure for the rough figure. So now looking at this, DA goes like this. This is perpendicular to AB, like this. So this is A, this is B, this is D. And you can see that this is 8, while this is only 5. Okay, so 8 is this lengthy, 8 centimeters. So 5 should not go longer than that. Right? So 5, we stop it more than half the way, we just stop like this. So this is 5 centimeters. And this is obviously C. Now we'll have to join BC. And we are also given that this is 5 centimeters. Yeah. Am I right, children? Is it clear? It's not easy to draw this figure, like in the first. As soon as you read this information, see if you can do it, good. If you can do it, very good. I always take take the help of a diagram like this. I always represent the information given a rectangle and then I make the rough diagram. Yeah. So now the question is to find the area of the quadrilateral. Find the area of the quadrilateral. Now this quadrilateral is a trapezium because one pair of opposite sides are parallel. So it's a trapezium. And the formula to find the area of a trapezium is half into sum of the parallel sides. So half into 8 plus 5 into the distance between them. The distance between them is not 5 centimeters, children. Distance between them, distance is always the perpendicular distance between the parallel sides. Distance is always the perpendicular distance between the parallel sides. Supposing this was given, supposing this one was given, whatever, like 4 centimeters, this was given, then you can take dA. dA is the perpendicular distance between the parallel sides. But dA is not given. You cannot take 5. BC is not the perpendicular distance between the parallel sides. So you cannot take 5 centimeters as H. So we need to take a construction through C. Through C, draw CM perpendicular to AB. Through C, draw CM perpendicular to AB. So like this. Through C, draw CM perpendicular to AB. All right. So let me draw that figure again. And draw this one again. So now this is also 5, right? Then how much is MB? 3 centimeters. 3 centimeters. Draw CM perpendicular to AB. Now DC, now this one becomes a rectangle. This one is a rectangle now. This one. Opposite sides will be equal. So if this is 5, this is also 5. But the whole thing is 8. So MB will be 8 minus 5, 3. So you can add and see 5 plus 3, 8. AB is 8. No, AB is 8. AB is 8. You can see 5 plus 3, 8. 5 because opposite sides are equal. So since DC is 5, AM is also 5. So MB will be 8 minus 5, 3. Now we need to find CM. We need to find CM. So in right triangle CMB, which is the hypotenuse? In right triangle CMB, which is the hypotenuse? CB is the hypotenuse. CB. So how do we apply Pythagoras theorem? CM square plus MB square is equal to CB square. In right triangle CMB, in right triangle CMB, CB is the hypotenuse. CM, MB are the legs. CM and MB are the legs. CB is the hypotenuse. CB is the hypotenuse. Square all the sides. Hypotenuse should be alone on one side. It should be separate on one side. Find the sum of the squares of the other two sides. So this is the result by Pythagoras theorem. CM square plus MB square is equal to CB square. Now what is CM? We don't know. We need to find CM. So CM square plus MB square, 3 square, is equal to CB square, 5 square. So CM square plus 9 is equal to 25. Cm square is equal to 25 minus 9, 16. 25 minus 9, 16. Cm square is equal to 16. So Cm is equal to the square root of 16. Cm is equal to 4 centimeters. So the distance between the parallel sides is 4 centimeters. Now area of, it's given quadrilateral. So you can write quadrilateral or you can write trapezium also. Because opposite sides are parallel. It's a trapezium. Or you can write quadrilateral. Whatever. So area of, I'm going to write trapezium. Area of trapezium, ABCD. Area of trapezium, ABCD is equal to half into sum of the parallel sides, AB plus CD, AB plus CD, into the distance between them, CM. So half into AB plus CD, 5 plus 8, into the distance between them, 4. So half into 13 into 4. 2 ones are 2 twos are 13 twos are 26 centimeters square. So the area of the trapezium is 26 centimeters square. So it's a very simple question, just that the distance between the parallel sides is not given. So you have to find that using Pythagoras theorem. So find it using Pythagoras theorem and then use the formula. Yeah, right on, children?
Ma'am, can you go to the next slide for a minute?
Oh,
Yes, ma'am, thank you.
all right.
Done, ma'am.
Yeah. Ashriya, you can just take a screenshot. The offline students are still doing the slide. I'll just show you the next slide. You can take a picture and continue.
Take it, ma'am.
Yeah. done this one? Yeah.
Ma'am, will we be doing another question now, or may I be excused for a couple of minutes?
Oh, I didn't notice the time. No. That's it for today's session, Aishwarya. You can leave the call. If you're finished, you can leave the call. Yeah. I didn't notice.
Okay,
Yeah.
thank you.
Yeah. Yeah, online students. So that's it for today's session. I didn't notice the time seriously. Thank you so much. You may leave the call if you're finished. Surya and Lakshana.
Yes, ma'am. Thank you, ma'am.
All right, Surya. Thank you. Yeah. Finished, Lakshana?